Hi everyone. Today we're talking about domain and range. So domain and range are basically domain's the set of all inputs for a function, and range is the set of all outputs for a function. So let's write down those definitions. Once again, these notes are on Moodle already, or Canvas, depending on what system you're using. The domain is a set of all possible x values. Range is the set of all possible y values. So first things first is we should review what's called interval notation. Because interval notation, your MyOpenMath is going to want you to use interval notation. So real quick, make sure you pause if I go too fast, or watch it in slow motion. So here's a review of interval notation. We have the inequality, and then over here we got a number line, what it looks like on a number line, and then what it looks like in interval notation. Remember, in number lines we use closed circles to indicate that we include that point, and open circles to indicate that that point is not included. Open circles are going to translate to parentheses in interval notation. Closed circles are going to translate to brackets. So x is less than a on a number line. You have an open circle at a, and you got all the business to the left. That's x is less than a. Interval notation, well, this arrow right here points at negative infinity. So my interval notation is negative infinity, comma a. The infinities are always going to have parentheses. Less than a, so we have parentheses. Less than or equal to a, the circle is closed on the a. Interval notation, negative infinity to a with a bracket on the a. All right, so when you're doing the MyOpenMath assignments, you just got to make sure you choose the correct bracket or parentheses, depending on your situation. So x is greater than, I guess for greater than we use b. So x is greater than b. Open circle at b, we want all the business to the right of b then. This arrow now points at positive infinity. So my interval is going to be b comma infinity, parentheses on both. And then x greater than or equal to b, you'd use a bracket. So greater than or equal to b, you'd go bracket b infinity. All right, then you have the ones that are have both. So we have a fully opened interval. A is less than x, is less than b. You have two open circles, and x is between those two values. Remember, open circles are parentheses. So this is just going to be a, b in parentheses. Then we have some half open, half closed intervals. A less than or equal to x, less than b. The circle is closed on the a and open on the b, so I have all the business in between those two. So bracket a, comma b, parentheses. And then you have the half open, half closed interval with the b having the bracket. So I think I'm doing all the cases here. So I have parentheses on the a this time, bracket on the b. And then I have the fully closed interval. So I have both a and b have closed circles, so they both have brackets in the interval notation. The last one to consider is if x is any real number. So if x is any real number, I am between infinity and negative infinity. So then the whole number line is filled in, the whole number line is shaded in my interval notation, negative infinity to infinity, both parentheses. Always parentheses on the infinities, because in theory you can never get there. Alrighty? Alright, let's practice how to find domain of some functions. So first example, we want to find the domain of this function right here, x plus 6 divided by x squared plus 7x plus 12. We want to find the domain. So a couple things we can't do in the real number system. Number one is we can't divide by 0. So you cannot divide by 0. So our domain can include any value that doesn't make the denominator 0. So whatever makes the denominator 0 has to be ruled out as being a possible domain element. So whatever makes the denominator equal to 0 is not in the domain. So a good way to do this one then would be to take that denominator, x squared plus 7x plus 12, and just set it does not equal 0. Then we got to factor, right? We're going to factor x squared plus 7x plus 12. So it's understood that you're supposed to know how to factor coming into Math 111Z. So I am just going to say this. You have to figure out what multiplies to 12 and adds up to 7. So that's 3 and 4. So my factorization is x plus 3, x plus 4. Does not equal to 0. Okay. Then you would just set each one of those factors does not equal 0 then. So x cannot equal negative 3, and x cannot equal negative 4. If x equals either one of those two things, then you have a problem because you're dividing by 0. We talked about asymptotes a little bit in the last section at the end. You're going to end up with vertical asymptotes at negative 3 and negative 4 for this one. So we'll be talking more about that in section 3.7. So another way to state answer is by what we call set builder notation. So set builder notation says this. You have these fancy braces. You put an x in, and then you put a vertical bar, and then you do x does not equal negative 3, and x does not equal negative 4. So this says that the answers are x values, and the vertical bar means such that. And then you got the condition over here. So the domain is any x value such that that x value does not equal negative 3, and that x value does not equal negative 4. Alrighty. Let's talk about square roots a little bit now. Talk about square roots. You know in the real number system that taking the square root of a negative is a naughty thing to do. You can't. You just can't square root negatives. So if I give you this function right here, f of x equals 5 times 7 minus 3x plus 2, thou shalt not square root a negative. Therefore, this number, 7 minus 3x, has to be 0 or above. So all I'm going to do to find the domain here is I'm going to take 7 minus 3x, and I'm going to set it to bigger than or equal to 0. So then I solve it. So subtract 7 from both sides. Negative 3x is greater than or equal to negative 7. Then I'm going to divide both sides by negative 3. Now hopefully there's a bell going off in your head. Ding, ding, ding. I'm dividing both sides by a negative of an inequality, so the direction of the inequality sign must flip. So x has to be less than or equal to 7/3. Let me write that down. Whenever you multiply or divide both sides of an inequality by a negative, you flip the direction of the inequality. Alrighty. So x is less than or equal to 7/3 is our answer. This time my open math wants you to put it in interval notation. So if I put it in the number line first, here's 7/3. I want less than or equal, so I got a closed circle and I want all that stuff to the left. Check it out, this arrow here to the left points at negative infinity. So my interval notation is going to be negative infinity to 7/3. Never a bracket on infinity, so that's a parentheses. The 7/3 is a filled in circle, so that's a bracket. So there's my domain. Let's talk about how to find domains and ranges if you're given the graph. Alright, so I'm given a graph of f of x. Here it is right here. My y-axis, my x-axis, and we're going to go each of the slash marks represents 1 again. And then let's draw some graph. Okay, so I got the point negative 2 comma 1 is an open circle. You got the point 2 negative 3 down here, so I'm going to swoop down. And then it goes up to, it looks like 7/3. So then it's going to swoop up to 7/3. Okay, here we go. So domain, so the way I like to think about it is if I squash that graph onto the x-axis, right? If we squash that graph onto the x-axis, you're going to have this number line right here. The domain is the set of inputs. The set of inputs is the x values. So there's my domain. If I squash that graph onto the x-axis, I got my domain. So my domain is negative 2 up to 7. Open dot on the negative 2, so I have that's in parentheses. My range is going to run, it's going to be the y values. So my range is really going from negative 3 up to positive 3. So if I squeeze it on the y-axis, that's going to indicate my range. So my range is going to be negative 3 to positive 3. Everything is included, so they're both brackets. Alrighty, everybody? So there's domain and range if you're given the graph. Next thing, we have a function that's cut up into pieces. So let's look at one. It's called piecewise defined. All right, so this is a piecewise defined function. Basically, it's telling you to use different formulas depending on what the domain is. So f of x equals, is saying use the formula 3x minus 7 if x is less than 1, and we're going to use 5x plus 3 if x is greater than or equal to 1. So when I ask you to find out, like, what is f of 0, First thing you need to do is need to figure out where 0 is. Is 0 less than 1, or is 0 greater than or equal to 1? 0 is less than 1, so I'm going to use the top formula to calculate f of 0. So 3 times 0 minus 7 is negative 7. Then f of 1, I would have to use the second one for f of 1, because its x is greater than or equal to 1. So 5 times 1 plus 3. I would have to use the second one. And I get 8 for that. Then what if I asked you to find f of 3? Well, is 3 less than 1? No. Is 3 greater than or equal to 1? Yes. So I want to put 3 into the 5x plus 3 again. So it looks like I get 15 plus 3 is 18. So that would be how to evaluate functions that are piecewise defined. Last example, let's graph one on how to do it. All right, we'll graph one. Okay, everyone, I switched over to MyOpenMath to do this last one. We are going to sketch a graph of f of x equals negative 1 if x is less than or equal to negative 2. So here's x equals negative 2 right here. So when x is less than or equal to negative 2, I want the horizontal line y equals negative 1. If I were to graph y equals negative 1 for all real numbers, it's going to go right here where my arrow is. But I only want to do it for when x is less than or equal to negative 2. Therefore, I'm going to put a dot on that point right there. So select the dot, and you're going to see a little pencil on MyOpenMath. Just put a dot there. And then I want everything to the left of that on negative 1. So then I choose this one right here. That's my ray feature. Then I draw it going out that direction. So that is y equals negative 1 if x is less than or equal to negative 2. Now I want y equal to x. So if x is negative 2, y is negative 2. If x is 1, y is 1. If x is 0, y is 0. So negative 2 less than x, I got to have an open circle at negative 2, negative 2. Right? Open circle because it's negative 2 less than x. And then 1, 1, closed circle because it's less than or equal to. Then I need a line segment between those, so I'm going to grab the line segment tool right there and draw in between those two. And there you go. So that's the second piece. And then for x is greater than 1, I want y equals 3. So y equals 3 is this horizontal line up here. X is greater than 1. I need the open circle again right here on 1, 3. Then I want everything to the right. Everything that direction. And that should do it. I should be able to submit my question. And yep, got it all right. Good job, team. So there you go. There's the domain and range section. Please, this piecewise defined function stuff's pretty difficult. So if you're struggling with that, please pop in office hours to go help. All right. See you later.